In this lesson, we're going to start by solving radical equations. So in the first problem, we're solving for y. We have the square root of y equals 2. So we need to get rid of the radical sign in order to solve. So since we're dealing with square root, in order to get rid of the square root, we're going to square both sides. So the square root of y squared is simply y, and 2 squared are 4. Our next example, solve for u. We have the square root of u plus 7 equals 5. So again, what we're going to do is square both sides. That gets rid of the radical sign, and that leaves us with u plus 7 equals 25. And then we finish solving for u by subtracting 7 from both sides. So u would equal 18. Our next problem, again, we're solving for u, and we have the square root of 5u minus 6 equals u. So again, we want to get rid of that radical sign by squaring both sides. So the left-hand side becomes 5u minus 6 equals u squared. Now we have a quadratic equation. So remember what we did with a quadratic. We need to make sure we set it equal to 0 and solve. Most people will tend to move the u square on the left-hand side, but I would strongly recommend keeping the u squared positive. So I'm going to subtract 5u and add 6 to both sides. So the left-hand side becomes 0, and we have u squared minus 5u plus 6. So what I need to do next is to factor. So we'll use the shortcut in factoring. Since our leading coefficient is 1, we only have 1u squared, we can go directly into the factoring. So we know it's u times u to give us the u squared. To get a positive 6 when we multiply and a negative 5 when we add would be a negative 3 and a negative 2, because negative 3 plus negative 2 is negative 5, and negative 3 times negative 2 is a positive 6. So next, we set each factor to 0 and solve. So here we add 3 to both sides, so u would equal 3. In the second one, we add 2 to both sides, so u would equal 2. Our next example, we're going to deal with a different root. We're going to deal with the fourth root of x equals 3. So the process is the same. Since square root, we squared to get rid of the radical. If it's fourth root, we're going to raise both sides to the fourth power. So the fourth root of x raised to the fourth power just gives us x. And then 3 to the fourth power is 81. So again, we're undoing. We're doing the opposite. The opposite of the fourth root is raising something to the fourth power. Now our next problem, we're dealing with rational exponents. So it's the same principle. So just to remind you what a rational exponent is, when I have u to the 1/4 power, that's the same thing as the fourth root of u raised to the first. So the index, this number on the outside of the radical, is whatever our denominator is, and the numerator is the power in which it's raised, in this case, to the first power. So how do we solve this? So what we can do is raise both sides to the reciprocal of the exponent. So I'm going to raise both sides to the fourth power. And you see what happens on the left-hand side, it reduces and just leaves us with u to the first equals 3 to the fourth power, and 3 to the fourth power is 81. So let's look at the next example. So here we're solving y minus 8 raised to the 2/3 power, and that equals 2. Now this is a little bit trickier because we're going to deal with something a little bit different when we take the reciprocal. So in order to get rid of the 2/3 power, I'm going to raise both sides to the 3/2 power. So with this becomes y minus 8 equals the square root of 2 to the 3rd power. Now, since we're dealing with the square root, as we talked about before, we would have two answers, the positive and the negative. So we would also have y minus 8 equaling the opposite of 2 to the 3rd power. Again, because of our denominator being 2, and since we're taking the square root, we're going to have two answers. So this would be y minus 8 equals the square root of 8, and y minus 8 equaling the opposite of the square root of 8. We have to simplify the square root of 8. So we have y minus 8 equals the square root of 4 times the square root of 2, or y minus 8 equals 2 square roots of 2. And on the other side, we have y minus 8 equals exactly the same thing, the square root of 4 times the square root of 2. So y minus 8 equals the opposite of 2, or negative 2 square roots of 2. Now we need to add 8 to both sides. So one of our answers would be 8 plus 2 square roots of 2. And the other answer when we add 8 would be 8 minus 2 square roots of 2. So again, it depends. In this case, again, since we're taking square root, our denominator being 2, we're going to have two answers. Our next problem deals with factoring and solving something that's different than quadratic. So there's a couple of different ways to do it. Instead of it being y squared minus 17y plus 16, you notice we have y to the 4th minus 17y squared plus 16. So what we do is we use substitution. And a lot of times what they do is they use the variable u, or sometimes they use a. It doesn't make a difference what variable you choose as long as it's different than the one given. So I'm going to use a, and so I'm going to say let a equal y squared. So when we look at y to the 4th, that's really y squared squared, because 2 times 2 is 4. And here we have 17y squared plus 16 equals 0. Now if we put a anywhere we see the y squared, so this becomes a squared minus 17a plus 16 equals 0. Now we have a quadratic equation. So now we're going to factor using the shortcut. How do I know I can use the shortcut? Because my leading coefficient is 1. So what I'm going to do is write a and a, because that's how I get my a squared, a times a. I'm looking for the factors of positive 16 that add to a negative 17. So that'd be a negative 1 and a negative 16. Because negative 1 minus 16 is negative 17, and negative 1 times negative 16 is positive. So now I set each factor to 0, and solve. So in the first one, a equals 1, and the second, a equals 16. Well, hopefully you're looking and saying, well, that's not the original problem. The original problem had y. You're correct. So at this point, we take the y squared and plug it in place of a. So again, our answers were a equals 1 and a equals 16. So if I put y squared back in place of the a, I can now solve using the square root principle. Keeping in mind, when I take the square root, I have two answers. So y equals positive and negative 1. And for the second one, when I take the square root, again, two answers, positive and negative. The square root of 16 is 4. So I have positive and negative 4. So I had 4 answers. The next problem, we're dealing with finding the domain of a radical function. So the domain, remember, are our x values. So what restriction is there to a radical? We know when we're talking about the set of real numbers, not complex, the value underneath the radical sign has to be greater than or equal to 0. So what we do when we're dealing with square root, we take our radicand and set it greater than or equal to 0. And now we solve. So x would have to be greater than or equal to negative 4. Now, how do we write that in interval notation? So I write my boundary point, which in this case is negative 4, and this is read from your variable. So the values that are greater than or equal to negative 4. So they include negative 4 and all the values that are greater than is always to the right on the number line. So in interval notation, I start with my point furthest left from the graph, and that would be negative 4, comma, where my graph stops. This graph continues on forever, so it goes to infinity. Infinity always has parentheses because it's not a number. Only numbers that are included, like it is in this case, since this is greater than or equal to, since it's or equal to, I use a bracket for the negative 4, indicating that negative 4 is part of the solution. If it were just x is greater than negative 4, I'd have parentheses on both ends. So let's look at the next one. Find the domain. Again, my radicand, negative x plus 2 has to be greater than or equal to 0. So now I solve. So I'm going to subtract 2 from both sides. And this gives me negative x is greater than or equal to negative 2. Now keep in mind we're solving for x, and anytime we divide by a negative, the direction or the sense of our inequality sign changes. So negative 2 over negative 1 is positive 2. So my answer here for the domain is all x values less than or equal to 2. So again, I'm going to come to my number line, put in my boundary point, which in this case is 2. It's included because of the or equal to part. Now, which direction is less than? Less than always is to the left of the point. So in writing my interval, how far left is my graph to the furthest point right? Since this graph continues indefinitely to the left, that starts at negative infinity. Where does my graph stop? What's the furthest point right? It's 2. Since 2 is included as part of the answer because of the or equal to part, it gets bracket. Infinity is not a true number, so it's not included in the solution. So it'd be parenthesis negative infinity, comma 2 bracket. Now the last example is a little bit more complicated because we have 2 restrictions. What are the restrictions that we see or should see? First of all, we have a fraction. So we know that our denominator cannot equal 0. So we know that negative x minus 4 cannot equal 0. What else do we have? We have a radical. So how do we find the domain of the radical? We set the radicand, which is x plus 7, greater than or equal to 0 because it's in the numerator. We can have the or equal to part. And now we solve. So for the first, we're going to add 4 to both sides. So we have the opposite of x cannot equal 4. And then we divide both sides by negative 1. So x cannot equal 4 divided by negative 1 is negative 4. So that's one of our boundary points on our graph, negative 4. So x cannot equal negative 4. Also, x plus 7 is greater than or equal to 0, so I'm going to have to solve by subtracting 7 from both sides. So we also know that x has to be greater than or equal to negative 7. So now we put our boundary points on the number line. We put negative 7. Negative 4 is larger than negative 7, so it's to the right. Now we pay attention. X cannot equal negative 4, so I'm going to put an open circle telling me it cannot equal negative 4. It says x is greater than or equal to negative 7. Since it can equal negative 7, that gets a solid point. So the values that are greater than are to the right. So our graph would go here and not include negative 4, but then continue past negative 4. So now let's look at our boundaries. Our first segment begins at negative 7 and ends at negative 4. So since it includes negative 7, we use bracket. Since it doesn't include negative 4, we use parentheses. So now we've taken care of this part of the graph. Now we have to take care of the rest. So since there's another segment, we use union. The second segment begins at negative 4 and continues indefinitely to the right to infinity. Remember, infinities get parentheses, and since negative 4 has that open circle, it's also not included in the solution. So our final answer would be brackets, negative 7, comma, negative 4, parenthesis, union with negative 4, comma, parenthesis, infinity, in parentheses.